Oh, I'm already live. I'm currently editing the title and thumb and okay. All right. There we go. And um I'm gonna be lagging this whole time. Am I live already? Wow, okay, I'm already live. So yeah, let's just get started. I might need some more light here in a little bit. Let's see what it, and I'm gonna turn on some music. If y'all can hear music, please tell me. Actually, I'm gonna turn on some no copyright music just in case y'all can hear it. I'm pretty sure y'all shouldn't be able to. I mean, let's just turn on some NCS music just in case. Just for now. If y'all can't hear anything, just say like yes, we can't hear anything, and I can put on some other music. Hello there. I am. Let's see. There we go. So we can write things. All right, let's go ahead and start the world record. You know what? Actually, I like this music. It's gonna. So our first equation equals. So we're just gonna start with some separable as like a little warm up. Then we'll get into the interesting ones later. So now, since this is hopefully separable, let's go ahead and try to get all the y terms on one side. Yeah. So this is going to become y over y squared plus y plus 1 dy equals 1 over x ln x dx. Is that x ln x? No, that should be x squared. And this should be y plus 1 all squared. So that's going to be two integrals we need to solve. Um, if y'all could tell me how the stream is faring in terms of like lag and stuff, like audio quality, that'd be really nice. So we're gonna go ahead and integrate on both sides this integral y over It's going to be y squared plus 2y plus 1 dy. Actually, no, y squared, y plus 1 all squared. We're going to do partial fractions. Going to equal, so y plus 1 all squared equals, that's going to be a times y plus 1. So we're going to have y equals a times y plus 1 plus b times y plus 1 all squared. This is just the partial fractions that I did quickly in my head. I multiplied everything that by y squared plus 1. This actually will just be b because the denominator would be that. So now we know that a, due to the coefficients, a equals 1 and a plus b equals 0. So b equals -1. So this equals 1 over y plus 1 minus 1 over y plus 1 all squared dy. This equals ln y plus 1 plus 1 over y plus 1. That equals, now this integral is going to be interesting, 1 over x squared ln x dx. This integral, we have x, we could do integration by parts. Differentiate, we have 1 over x squared for some reason I don't think that's right, but I feel like we can integrate this though. Just gonna have to be a little smart. Integration by parts could work, but I'm thinking there's got to be a better like u sub that we could do. Let's just try u equals ln x du equals 1 over u 1 over x dx. So I mean this equals 1 over u times du, and then solve for x. X equals e to the u. Okay, x equals e to the u. Oh, okay, so yeah, this is just gonna be a special function. E to the u. So now this integral is just integral of 1 over, or e to the minus u all over u du, which is going to be ei, the exponential integral of u. So plug in ln x is going to be ei of ln x. And then this is going to be plus c, we'll save that for the end. So yeah, that's that. Now we have our solved differential equation, ln y plus 1 plus 1 over y plus 1 equals ei of ln x plus c. I wonder if there's any way I could solve for y, but for now I think this was fine. So we're going to save that, and we're going to go on to the new problem. Where's my mouse? There we go, add page. So we just did a problem in like 4 minutes. So 4 minutes per problem, 50 problems. It's 250 minutes, not problem 4. Problem 2. So we're going to have you know what? I should break I should change the title. There we go. More interesting title. Alright, so we're gonna rearrange this. This becomes 1 over square root of 1 minus y squared dy equals x dx. Integrate both sides. Now, I believe that this is arc sine. Inverse sine of y equals 1/2 x squared, then plus c. So now we just have our solution, y equals sine of 1/2 x squared plus c. All right, that was easy. Let's hope. Oh wait, no, I want all right, so now so we're just doing the separable differential equations. And I know I'm working a little fast, but this is sort of like a warm-up. So this is our first initial value problem. Y of 2 equals 2. Or this is an initial value. This is just a value problem. All right. Rearranging, we got 1 over y squared minus 1 equals 1 over x squared minus 1. This is dy, this is dx. So the thing about a separable differential equation is that you're able to separate the dy and the dx using algebra. So if you notice, like I just sort of did cross multiplication, however you want it. Move the dx to the numerator over here, move the y squared minus 1. When you integrate, there's a fast way to integrate this. This gets us arc tan h, so the inverse tan of y equals the inverse tan h of x. That doesn't seem right, but at the same time it does. Oh wait, no, we gotta look at this condition. I believe this is actually now inverse cotan h of y equals inverse cotan h of x. But they should equal the same thing, just differed by a constant, so y equals x plus c. Because if you take the cotangent or tangent of both sides, you should get... I'm going to have to check on this one later. But, so now that we've got x plus c, we have 2 equals 2. We just plugged in these. And so now we just have c equals 0, so y equals x. I hope that's right. It probably should be right. All right. So now we've got our first this is our first integrating factor problem. So first we're going to want to get the function of p of x times y on this side. So this becomes dy dx minus 2y equals x squared plus 5. This is our function of x. Our mu of x equals just e to the minus 2x, or integral of this dx, e to the integral of that. So now this will equal the differential of our mu of x, that times y equals move the dx over here, x squared plus 5 dx. Integrate both sides. Integral of a differential is just the thing inside. And then this equals a third x cubed plus 5x plus c. Y equals, were there any boundary conditions? Nope. So we got 1/3 x cubed e to the 2x plus 5x e to the 2x plus c e to the 2x. Or you could factor the e to the 2x. Doesn't really matter. So now we do problem 5. Yeah, these differential equations are going to get very hard very quickly. Very long, and x plus 2 all squared, dy dx. If you are watching this and you're unsure what a differential equation is, a differential equation is any equation with a differential in it. So like a dy or dx or a y prime, or x dot, something like that. It indicates a derivative. So first off, we're going to want to move this over here. So we have x plus 2 squared dy dx equals, or no, plus 8. I factored out the y equals 5. Divide everything by this. We can factor out an x plus 2. So this becomes 2 or 4 times x plus 2 all over x plus 2 all squared. This and that will cancel. That becomes a 1. Mu of x e to the integral of 4 over x plus 2 equals e to the ln of x plus 2 all to the 4. The e and the ln will cancel, so this just equals x plus 2 to the 4. So now we have the differential of x plus 2 to the 4 and y equals 5 dx. So now we have x plus 2, integrate both sides, plus 2 to the 4 y, 5x plus c. So y equals 5x plus c all over x plus 2 to the 4. All right, problem 6. X squared minus 1 dy dx plus 2y equals x plus 1 squared. All right, so now we divide everything. Y dx equals, not equals, I keep putting that, 2 over x squared minus 1 y equals, we can do some factoring. Basically, this is just going to be x plus 1 over x minus 1. Due to, this is a difference of two squares. This is just a square. We canceled x plus 1. Mu of x equals e to the integral of 2 over x squared minus 1 dx. Now I could do the arctan h or the cotan h, but I think a better way would be writing this in terms of logarithms. So to evaluate 2 over x squared minus 1 dx, we're going to do partial fractions. So I already factored this. We'll use the cover-up method. Add x equals 1, b equals 1. So like at x equals 1, right? Because 2b equals 2, yeah. And at x equals negative 1. Oh wait, no. At x equals 1, a equals... Yeah, oh, no, never mind. X equals 1. Yeah. At x equals negative 1, a equals negative 1. So this equals integral of negative 1 over x plus 1 plus 1 over x minus 1 equals ln x minus 1 all over x plus 1 plus c. I just use some properties of logarithms there. We don't need the plus c with our integrating factor. So this equals e to the, hold up. Oh yeah, this is good. Ln x minus 1 over x plus 1. This net cancel equals x minus 1, x plus 1. All right. Oh my God. Hold on, I'm gonna do something real quick. Hold up. Hey, what's up, y'all? Anyone in here? I'm currently streaming. All right, never mind. I'm not doing that. All right. So now we do our multiplication. We have a differential of x minus 1 all over x plus 1 times y equals, this and that are going to cancel when we multiply. This just equals 1 dx. So we have x minus 1 over x plus 1 equals, or times y equals x plus c. Y equals x squared plus cx plus c. All over is that right? X squared plus cx plus 1 c plus 1 x plus c all over x minus 1. All right. Next problem. All right. Problem 7. Minus sine of x squared y. I'm pretty sure we're gonna have to use special functions on this one. Y of 0 equals 5. So yeah, just straight up our mu of x I believe is e to the negative integral of sine of x squared dx, which is the e to the negative si of x. No, as just s of x, right? So now we have differential of e to the minus s of x times y just equals 0 dx. Integrate, we have y equals c times e to the s of x, where s is the, I forget what it's called, but it's basically just this integral right here. So now we got to evaluate s of, so 5 equals c e to the s of 0. S of 0 is going to be integral from 0 to 0 of sine of x squared just equals 0. So this goes to 1. So now we have c equals 5. So y equals 5 e to the s of x. Okay, I hate having s and 5 in the same problem. All right, problem 8. We're almost a fifth of the way there. But, you know, that's kind of misleading because the problems are just going to keep getting longer and longer as we get into the second order non-homogeneous differential equations. And also, if you can hear the music, please tell me because I don't want to get copy strike. All right, so now we got 1 over x. So this is, I believe, an exact DE. We have to make it exact. Minus y over x squared plus y squared dx plus y e to the y x over x squared plus y squared dy. All right, so this is m, this is n. The partial derivative of m with respect to y equals, you just only have to differentiate this term, which is going to be low d high, x, or negative, because of this negative sign, x squared plus y squared d high, which is 1, minus high d low, which is 2y plus x squared all over the square of what's below, x squared plus y squared all squared equals This and that cancel. No, they don't. They do not cancel. So we have 2y squared minus y squared. It's just going to be y squared. We have xy squared minus x squared, which is just going to be so y minus 1, oh, y minus 1 times x squared all over x squared plus y squared. So now we want to find the partial of n with respect to x to see if they're the same, which is going to be this term that goes to 0, low d high, which is 1, minus high d low, all over the square of what's below. All right. That's going to be, we're going to have the negative x squared Are these seriously non-exact? So we have the negative x squared oh no, these should go away. Okay, I did the differentiation wrong. Yeah, so when we treat x like a constant. Um so low d high minus high d low, so this x squared should go away, and vice versa, this y squared should go away. Okay, so now that the x squared goes away, we just have x squared, oh my goodness, nope, x squared minus y squared um, all over x squared plus y squared all squared. All right, so now we do the same with this. Should that be minus? Yeah. No, no, no. This should be plus. This should be minus. And that's what we get here. We have minus x squared plus y squared all over x squared plus y squared all squared. And so since the partial of m with respect to y equals the partial of n with respect to x, this is exact. And we can use the following method. So we can say that this equals the gradient of some function, df dx df dy. So if we want to find f, let's just integrate this term with respect to x, which is going to be that. So let's integrate 1 over x. With respect to x, this is going to be fine, yeah. Plus 1 over x squared minus y all over x squared plus y squared dx. This is going to equal ln x minus 1 over x plus y all over, oh no, we can't, well, we can integrate this, but this is going to be, yeah, that is really annoying to integrate. So we can't do that. So whenever we can't really do that, we choose the other one to integrate with respect to a different variable. So this one, the y e to the y plus x. Oh no, we run into the same problem. Okay. Oh wait, no, we can integrate that. What am I thinking? Yeah, that's just arctan. Arctan x over y. That is, yeah, arctan x over y. So we have ln x minus 1 over x minus arctan x over y. Okay, so we've got that. And then not just that, but we have to add a function, arbitrary function of, well, it's not really arbitrary, but a function of h, or of y, not of h. The reason we have to do that was because this was just the partial, which means that if we differentiated this, uh, if we added this h of y term, this would still be true. So, okay, I'm vibing to this music too much. If y'all can hear it, please tell me. So now that we've got this, this should equal, we should differentiate this now with respect to y, and that should get us this term right here. So if we differentiate with respect to y, we get 1 over x. With respect to y, this term goes away. Derivative of inverse tan of x over y with respect to y. That's going to be, well, first we multiply by the chain rule, which is going to be 1 over y squared times x over x squared plus y squared. Is that right? No, we don't have to do that. Yeah, we do. And then plus h of y. Yeah, okay, now this should still work. Equals this term, which is going to be y e to the y plus x over x squared plus y squared. So there should not be this 1 over y squared here. And I feel like that should go away. But at the same time, so what's supposed to happen is this and that will cancel and we have our h of y. But before we do that, I'm going to have to figure out where I went wrong, which could either be in the integration. So I don't think we went wrong here in the integration unless there should be a y times. In that case, that doesn't fix anything. Now I could try rearranging and seeing if I can get, nah, they're supposed to cancel out completely. So before I do anything, I'm going to make sure I differentiated this right. So we want to differentiate negative inverse tangent of x over y with respect to y. So we know that we're going to have Oh wait, yeah, how did we get to this? Yeah, this is correct. Um, this would be if we differentiate it with respect to y over x. So yeah, this is correct. And our h of y equals y e to the y, or h prime. Sorry, that should be h prime because we differentiated with respect to y, but a partial derivative of just a function of y is an actual derivative. So now we can actually integrate both sides. H of y equals y e to the y minus e to the y plus c. So now our actual solution is going to be ln x minus 1 over x minus inverse tan x over y plus y e to the y minus e to the y equals c. That's our level set curve. So that one took a while. Problem 9. Okay, this one should be a bit better. No, it's not. Okay, I need to write this. And then plus 2y sine x plus ln y dy. So first we gotta check it's exact, and this equals 0. So we're solving for y. First we gotta check it's exact, so we know that dm, so this is m, this is n, dm dy equals 2y uh, did I miss a negative sign? Oh, and we forgot the initial conditions, y of um, 0 equals 1. Oh no, with respect to y, yeah, there's no sine x. It's 2y cos x. What am I thinking? Um, then with respect to y, negative 3x squared with respect to y. Yeah, and then dn dx equals 2y cos x minus 3x squared. All right, so it's exact. All right, so now that we know that it is exact, let's go ahead and solve it. We know that this is the gradient of some function. I'm using fundamental theorem of line integrals now, just because that's how we did this in Cal 3. Or no, this is f. So now we know f equals, let's just integrate, let's do that term with respect to y. 2y plus, or 2y sine x minus x cubed plus ln y dy equals y squared sine x minus x cubed y plus y ln y minus y plus some function of x. Let's differentiate y with respect to x, and we should get y squared cos x minus 2x, or not 2x, 3x cubed, or 3x squared, y plus, with respect to x, that goes 0, that goes to 0, h of x, h prime of x, and that should equal this thing right here, which is y squared cos x minus 3x squared y minus 2x. So we can see that h prime of x equals negative 2x, so h of x equals negative x squared plus c. All right, now plugging it, so now we have our level set, which is this y squared sine x minus x cubed y plus y ln y minus y minus x squared equals c. Plug in y equals 0, or x equals 0 and y equals 1. We have that and that cancel. Y equals 1, that cancels. So now we just have negative 1. Yeah, negative 1. C equals negative 1. So I guess we could just write y squared sine x minus x cubed y plus y ln y minus y minus x squared equals negative 1. We could switch signs if we wanted, but I think this works. All right, problem 10. So yeah, the problems are getting longer now, and I'm not excited for that. Let's go ahead and do this. This is x squared y cubed minus 1 over 1 plus 9x squared dx dy plus x cubed y squared equals 0. So first we're going to have to do some rearranging, but basically this is going to be our m, this is our n, mx, that's another way of saying partial with respect to x. Do we need mx? No, we need my. That's right, my equals 3x squared y squared minus 0, and then nx equals 3x squared y squared, so my equals nx, which implies exact. All right, so now let's just say f, or skip the writing out, and we just say this equals the integral of, let's just do the right-hand side. X cubed y squared dy equals 1/3 y cubed x cubed plus c, not c, or h of x. So then fx equals y squared x, not y squared, y cubed x squared plus h prime of x, which equals x squared y cubed minus 1 over 1 plus 9x squared. Also, I just realized my error on the other one. It wasn't really an error, just I know where the problem was, and it was correct. All right. So now we have this and that cancel. H prime of x equals negative 1 over 1 plus 9x squared. Integrate equals negative inverse tan of 3x. So now we have our f of xy So, oh wait, no, I skipped one. So we have cos x dx plus 1 plus 2 over y sine x dy equals 0. So since one of these n is in terms of just one variable, we're going to have to make this exact, because this already isn't exact. So our mu of, I think it's y equals e to the integral of nx minus my all over m dy. So, let's find nx first, and all right. What am I doing? I'm taking a break. I don't need to do that. Nx is just 1 plus 2 over y cos x, and then ny, or my, equals 0. So mu of y equals e to the integral of nx, which is minus my. It's just going to be e to the integral of 1 plus 2 over y dy equals e to the y times y squared. Oh, let me write this, y squared e to the y. So our final product, or not, we're going to multiply everything by this, and we get y squared e to the y times cos x dx plus y squared e to the y plus y e to the y times sine x dy.
that equals 0. So let's go ahead and integrate this part with respect to x. That's going to be y squared e to the y sine x. Y squared e to the y plus our function, since we integrated this one, of y. Then partial differentiate this with respect to y. And we're going to get, so f y equals y squared e to the y minus 2y, not minus, plus 2y e to the y times sine of x plus h of y. Did I miss something here? Maybe this was a half. This is y squared. Was this supposed to be 2 or 1? Yeah, I think this was right. um, yeah, we're in for a long night. All right. Something's not right here. And I'm thinking that there should have been a 2y somewhere here. Wait, hold on. What is this? Oh, yeah, this should be 2y because of that. Okay. Yeah, this is correct. Okay. Yeah, y squared um e to the y plus 2y e to the y. This should be h prime sine x. So h of y is just going to equal a constant. So we don't have to worry. Y squared. Do we have initial conditions? No, that's for the next problem. Y squared e to the y sine x equals our level set curve. Next problem. So now we have x squared plus y squared minus 5 dx minus, or it's going to be plus minus xy minus 1, or not 1, y dy equals 0, and then our initial condition is y of 0 equals 1. So this is not exact yet. This, I'm guessing, yeah, this something's gonna cancel out if we set. So this is our n, this is our m. Uh, so mx, no, not mx, my equals 2y. Nx just equals negative y. So we're gonna want to do n of y. No. Yeah, probably. Because we want it over n. Yeah. Okay. Mu of I'm just gonna make something sure with um okay, yeah, desktop audio is 0, so I shouldn't be hearing music. All right, we are good. All right. So, I feel like, hold up. Let me look at this real quick closely. Mu of y is going to equal, if we do integral of, let's try a mu of x, just testing. I think, no, yeah, it's mu of x, 100%. If we do negative, it's going to be, it's going to be 3y all over y, negative y times x plus 1. That cancels. This is dx. So mu of x, or it's e to the power of that. So it's going to equal um, 1 over x plus 3 cubed. Is that right? That's ln, that's 3. Wow, okay, yeah, that's gonna be tough to integrate, but we can do it. Wow, that's gonna be really tough to integrate. Because now we got, what, x squared plus y squared minus 5 all over x plus 3 all cubed. Actually, no, I don't think that'll be that hard to integrate. If we could do some integration by parts. No, yeah, that won't work, but if we try, so this is dx. Oh wait, no, hold on, integral. Plus negative x, y, x. Why am I doing x plus 3? This is just x plus 1. Um, Squared. I mean, if we just integrate that with y anyways. So, f, let's just integrate negative y all over x plus 1 squared dy. We just get negative 1/2 y squared 1/2 y squared all over, hold on, it's going to be y squared all over 2 times x plus 1 all squared. If I check right now, Hurricane Laura should be making landfall. So let's see, when is it? All right. All right. So now that we've got this, and then plus, of course, our h of x. differentiate with respect to x, and we get so fx gonna equal negative, or not negative, just y squared all over 2 times x plus 1 all cubed. No. Yeah. Yeah. Then that should be x plus 1. Okay. So this should equal then plus h prime of x equals y squared over x plus 1 all cubed plus x squared minus 5 all over x plus 1 all cubed. This cancels. We're barely at problem 12, guys. And it's already been like, what, an hour since I started the stream? No, probably like 30 minutes. No, it's been an hour since I started the stream. So at this rate, we're going to be 5 hours to 50 problems and 10 hours to 100. But we're barely at the short problem, so I'm guessing 16 hours? Yeah, no problem. No problem. Let's go ahead and integrate this. Integrate. First we're gonna do dividing, long division. Um, Let me do 1, 0, negative 5. That's how you divide things, right? I mean, I could try the long way, but I'm thinking it's this. So this should be we can always check. Integral of x plus 1 minus 4 over x plus 1. See, we've got x squared plus 1, or plus x, plus 1 minus 4. That's not it. This becomes negative 1. X squared minus x. Yeah, that's correct. So h of x equals 1/2 x squared minus x minus 4, or ln, yeah, just 4 ln x plus 1. All right, and I guess plus c if we want. So now our f of xy level set equals negative y squared all over 2 times x plus 1 squared plus 1/2 x squared minus x minus 4 ln x plus 1, I guess just be absolute value, equals c. Boom. Solved. No, it's not solved. We got to plug in the initial conditions at y of x equals 0. So that cancels, cancels, cancels. And y is 1. So we're solving for c. So I'm going to do that. I'll write the final equation down here. So we have negative 1 over 2 times 1 squared equals c. c equals negative 1/2. Now we have the final answer, y squared all over 2 times x plus 1 all squared plus 1/2 x squared minus x minus 4 times ln x plus 1 equals negative 1/2. All right, let's go ahead and move that back there. Okay, problem 13. This one we're going to start the substitutions. Yay. And we're still on first order DEs. That's impressive. X dy equals 0. So what are we subbing? We're subbing y equals t times x. Dy equals dt x or x dt plus t dx. So we're solving for dy dx, or no, just dy. Oh, okay, yeah, just substitute. So now we have x minus tx times dx plus x times x dt plus t dx equals 0. So I think things are going to cancel out with the dx's. That's a plus. Or no, that's a t. What math am I taking this year? Linear algebra and it's and the MATLAB. Hold on. Using MATLAB to do linear algebra, so like programming. Um, yeah, linear algebra. And then I'm also finishing up some differential equations. Mainly, it's applications to physics, alongside some numerical things with the differential equations. Um, then that's the first semester. I want to do abstract algebra, uh, but I'm gonna need to get better at doing proofs before I do abstract algebra. So I'm probably gonna get better at proofs, then do abstract algebra. Not as a class actually. That's gonna be more of a elective type thing where I just sort of self-study. 'Cause I just know I'm gonna have to take it again anyways, but it's still good to do it. So like abstract algebra and then statistics. So that's gonna be an actual class is statistics for sciences, which so like that's like the actual nitty-gritty statistics, not just like the AP statistics. Um, you know, have I taken real analysis or complex analysis? I plan on taking complex analysis first semester of my senior year of high school, and then real analysis that's gonna have to be self-study if I want to take it in high school. But I'm hoping to take Math 55A at Harvard. Um, Even if I don't go to Harvard, I'm hoping to take that class. That's basically like their real analysis plus complex analysis plus abstract algebra plus advanced linear algebra all in one class. I heard it's really hard, and that's what I want to do. At least. Yeah, I know. I'm not going that fast. That's the problem. Like I'm still on the simple problems, and I'm taking forever. So I just can't imagine what it's gonna be like with the longer problems. All right. So the tx x dx. Hold up. Something's not canceling. Tx dx. Yeah, these and that cancel. Now we have x dx plus x squared dt equals 0. No, wait, no, those don't cancel. What am I doing? What are my reference problems? So all of mine came from a book. Um, see if I can pull this up on this book right here. A first course in differential equations with modeling applications. So all of these examples came from that book. So I just sort of picked them out. Which ones would be good to do? Where? Yeah, they're from that book. I picked out. I went from each section to section. Uh, Picked out problems, and this is strictly solving DEs. So there's no modeling or word problems. Yes, so I said math world record just to be more encompassing, but yes, this is only DEs for now. Um, I plan on doing a more general math world record. This one was just more of a meme stream. I don't know. Not really memes. I'm actually gonna break the record, whatever it is. I'm setting the record, not really breaking it because there wasn't really a record to begin with. So if anyone wants to do this, they can go ahead and try. All right. And I'm actually saving all my problems now. So that way people can um that way I can maybe make like an actual list in the description after this is uploaded uh rather than having to go through the whole video. What am I doing here? I should multiply this out. We have x dx minus tx dx plus x squared dt plus t dx. No, tx dx. That cancels. Equals 0. We're solving for dx dt. Yeah, so no, we want dt dx because we got who cares? First order differential equation dx dt plus x times just 1 equals 0. So we can solve this. This is just a product of t and x. No, no, no. Our integrating factor mu of t equals e to the t. So this is just e to the t times x equals just 0. So x equals 0. That did not seem right at all. That's a trivial solution. Hold on, who said this had to equal 0? Okay, this does equal 0, but how do I... Let's go back to this substitution. Oh, let's just do separation of variables. That'll probably be better. We have 1 over x dx equals negative dt. Okay, I did say I wanted to self-study, but I will be honest, I'm not like super good at it. Um, if I do self-study, I do know what to do, but I prefer classes to self-studying. So, do you want tips for like studying or tips for the class? That's what I want to know. Let's quickly solve this. Um,
when I do classes, just study on and on and on. You know, I'd say I will say it is hard to get started for me. But I'm sure that's the same with everyone. I think my biggest strength is that I can last for a long time if I eliminate distractions. That's the key detail. I've got to eliminate distractions. So like right now, my way of eliminating distractions is like to not play games on stream, right? If I start playing games on stream, people are gonna get upset. So that's why I'm not gonna play games. Other forms of distraction would be so playing games, your phone, watching YouTube. Like I cannot tell you how many times I have said, "Oh, I'm just gonna pick out some music to listen to," and I end up watching like an hour of YouTube videos because of my recommended. Like, yes, I'm going out to pick out music, and then, uh, I just start watching YouTube videos. So you gotta be very careful with that. Um, I mean, even right now, I spent like a full 15 minutes looking up the situation with Laura, which is actually pretty good for us, but not looking pretty good for the people who it's getting hit. Where I live, like, so yeah, I spend a lot of time looking at the news. Let's go ahead and solve for y here. Y equals negative x ln x plus c. Okay. Um. No, we got our. Do we have any initial conditions? No, we don't. All right, new problem. Yeah. Now we've got negative y dx. No initial conditions, so yeah, I'm gonna have some really good videos to do um like just later on. Like they're gonna be pretty good videos. I'm not doing them now just because I don't think there's that much interesting I can do. I mean, I can obviously make videos solving math questions, but that's not amazingly interesting. There's plenty of people who already do that. Um, that's not exactly what I want to do for my channel, where I just solve questions all day. Um, so yeah, let's do this is tx squared times uh, t dx plus x dt. So that cancels, so now we just have root tx squared, or just x root t dx. Root t times t is t to the 2/3 or 3/2. Wonder how windy it is outside. Okay, and then this will be plus root uh this will be x squared
dt plus root, so this will be x squared root t dt. So this is we can also solve. Yes. This isn't this isn't an exact DE equation. This is a substitution equation. Um, if I was solving by the method of exactness, then yes, I would have to do that test. Uh, so like for each DE I also put a method I have to use, because sometimes you can use multiple different methods for the same DE. So for this one, I put do the substitution method. Um, and we'll notice that later on when we have Annihilator, variation of parameters, Green's functions, um, series, Laplace. So we're gonna have a fun stream. That's what I'll say. Let's go ahead and keep working. So we have this x squared times uh uh no dt times 1 plus root t equals negative x t to the 3 halves dx. Let's go ahead and put this on that side. Now we've got um, t to the negative 3 halves. I'm going to put the negative here. Negative t to the negative 3 halves. Negative t just to the negative 1 half equals 1 over x dx. And this is dt. So let's go ahead and integrate. This is going to be negative, add 1, that's 1 half, negative 1 half. So, or divide by negative 1 half, which is just going to be 2, times 2 over root t minus, minus 2 root t, equals ln x plus c, 2 over square root of y over x minus 2 square root of y over x. I should have simplified this first. That's going to be 2 minus 2t all over, so 2 times 1 minus t all over root t. So now we have, 2 times 1 minus y over x all over square root of t. So I don't think we're going to get an explicit way of writing this. So I'm just going to put this all as one term. So this is going to be 2 over square root of y over x times ln x minus root y over x. Just do ln squared x. And yeah, I'll also put the ln squared, square root of y over x, ln squared x equals c. Was there initial conditions? No. Hello, Lev W. How are you doing tonight? just casually setting a world record for differential equations. So it's our last substitution problem for of that type. Thank goodness, I hate those. Um, Hello, hello, hello. Are we good? For some reason it says I have 0 viewers, but someone just typed in chat, so that's obviously wrong. All right. All right. Let's get back to solving. Yeah, I really wonder how windy it is outside. Uh, it's only 20 miles per hour right now. That's not bad. That is true. Could model the rate of change of my viewership using step functions and transforms. Okay. All right. So let's go ahead and I just had a brain fart. Anyways, y equals tx. All right. Dy equals x dt plus t dx. We're gonna try to get through this one quickly. Um, and we have dy dx, so let's just go ahead and solve for that. Dy dx equals x dt dx plus t. So we have x times x dt dx plus t equals square root of tx, or not tx plus square root of t squared. So we have x squared times 1 minus t squared. Okay, so now we want to solve this. Yeah, I can see how we're going to solve this separation. X squared dt dx plus tx minus tx, that's going to cancel, equals x square root of 1 minus t squared. All right. If y'all can hear music, please tell me. I don't think y'all can because I don't want to get copyright, even though I'm literally listening to NCS just in case. All right, integrate both sides, and then we get uh, so let's solve for t in terms of x. T equals sine of ln x plus c, and t equals y over x. So then y equals x sine of ln x plus c. Any initial conditions? Nah. I like that. Y'all want to see my face? I mean, yeah, we can do that. Um, all right, now we're doing a Bernoulli dE. Dy dx minus y equals e to the x y squared. I'm surprised we're still on
first order DEs, but there's a lot of tricks you can do with first order. Like, yes, they're first order, but we've done a lot of nonlinear ones too. So let's do y equals, this is our n, so u equals y to the negative 1, du equals negative y to the negative 2 dy, dx, du dx. All right, so now we've got negative y to negative 2 dy dx minus, oh, y equals u to the negative 1, so this is u to the negative 1. So this is actually u to the negative 2. This should be, yeah, u to the negative 2. That's going to be important to do later. E to the x times, yeah. So now we divide everything by u to the negative 2. Du plus u equals e to the x. We can solve for this. Mu of x equals e to the x. So this is d of u times e to the x equals e to the 2x. All right. Integrate that. We have, excuse me. We have 1/2 e to the 2x. C u equals 1/2 e to the x plus c e to the minus x. So that's our u, so that means y will just equal 1 over that. 1 over, and we can simplify that, but I think that's fine for now. Do we have any initial conditions? No, that's for the next problem. Can y'all not see me? Message retracted, what just happened? Oh, I guess you deleted them. I was scared, I was like, did someone delete the messages? Okay, alright. Problem 17. Got root y dy dx plus root y cubed equals 1, and then y of 0 equals 4. Alright. Cannot see my face. How about now? I can see you. Yeah, 3/2 minus 1/2, 3/2, and then this should be negative. Okay, so now we do u equals y to the negative 1/2. So that means y equals u to the 1/2. No, negative. This should be negative. All right. Then y, so now that we've got y, dy dx equals, you have 1/2
I should have switched this around, but it's whatever. So we have negative 1/2 u to the negative 3/2 um, du dx. Yeah, this will be plus y to the u to the 1, not u to the 1, 1/4. No, 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 that can't be right. Oh, this should be negative. Oh, I know, 1/2. 1 minus 1/2. Um, negative 1/2. So dy, hold on, u equals 1 over root y. So square both sides. Oh, this should be squared. Um, yeah, so square both sides, we get y. So y equals 1 over u squared, so u to the negative 2. So that's where it went wrong. Okay. Alright, so now we've got negative 2 u to the negative 3. Minus 1 minus uh okay, something's not right here. And I think it's because my brain is already dying just from 17 problems. That's not good. Um, okay, hold up. I kind of want to skip this problem for now and come back to it when my mind is feeling fresh. So let's go ahead and erase everything except for the original problem. Y to the 1/2, not negative. Yeah, let's try that. Let's try that. Well, hold on, let's just rewrite this. Dy dx plus, this is y to the 3/2, so y to the 3/2 divided by y root y, which is 1/2, equals, oh, I see where I went wrong. This should be y to the negative 1/2. Okay, I can see how this probably complicates things. Uh, let's try writing this. Yeah, okay, so we're gonna have to do some worky work. I could maybe solve this through separation. So we have, okay, let's just write this in terms of root y. So we have 1 over root y minus root y, which equals 1 minus 1 minus y all over root y. Okay, honestly, I feel like I could solve this through separation and say be done with it. So, you know what? Let, maybe I can't solve it through separation. Hold up. Is that even integratable? No. We're gonna have to do the sub. Wait, no, 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 no. Hold up. Okay, something is definitely not right here. Let's just say I try separation. So we're gonna have root y over 1 minus y. We could do integration by parts. Equals dx. On the second line, so we have, this is root y cubed is y to the 3 halves, right? Then we divide by y to the 1 half. Okay, this is proof that my brain is already dead from just 17 questions, and we're doing 100 of these. Oh no, this is not going to be good. Yeah. Okay. This is proof that my brain is already dead. I just spent like 30 minutes on one problem just because I can't think. So u equals y to the 1 minus 1 half minus minus 1 half, just 3 halves? Hold up. It's the 1 minus n, which is negative 1 half. It's going to be positive 3 halves. Is that right? Um, uh, so then y equals u to the 2/3. So then dy dx equals 2/3 u to the minus 1/3 du dx. So we have so raise this to the negative 1 half, which is going to be u to the negative 1/3. There we go. We've got it. We've got it. We solved it. Or not solved it yet, but so now we just do some algebra. That's going to be 3 halves. All right. So we know our, let's make sure I did this right. Not that, this, no. Oh boy, we did this one wrong. Glad glad I remembered. think that means we also did this one wrong. Yeah. No. No, no, no. Oh my goodness. My brain is dying. Okay, this was the beginning of. No, no, no. We did that one right, so this one's good. So, but I'm pretty sure when you multiply, you're supposed to multiply the whole equation by mu of x. So this one is wrong. So we're gonna put a star next to it. And also, I think this one we're supposed to multiply. So we're gonna put a star and we'll come back to it. Hey, at least I found it. We're getting this record. So this one's good. This one works. This one works. All right. All right. So now we've got e to the 3 halves x times u equals 3 halves e to the 3 halves x dx. Uh, integrate both sides. E to the 3 halves x. So that means that we might have done this one wrong too, because our mu of x was this. No, we did that one right. That's good. That one we didn't have mu. We did separation. This one was also separation. This one's also separation. Okay. So equals. Okay, this is just going to be e to the 3 halves. This should be x. Do I have Discord? A Discord server. Um, you know what? I actually do. I haven't made it public yet because I haven't really finished it. I didn't really work on it that much though. I do have Discord, so if you want to add me, and then I can invite you to it later. I'll put my Discord in chat. All right, this one's done. Oh wait, no, that's not done yet. We had so that we solved for u, and u was y to the 2/3 or 3 halves. Let's solve. So y of 0 equals 4. Um, 4 to the 2/3 or 3 halves is 8. So we have 8 equals 1 plus c. So c equals 7. So now we have our final answer of y equals 1 plus 7e to the negative 3 halves x to the, so it's squared cube root of this all squared. All right, I will come back to those problems when I'm feeling it, but right now I'm not feeling it, so. How about once we get down to the end of the page? So this one requires a special substitution. Just u of x plus y. U equals x plus y. So special. Anyways, so now and then we gotta write we're gonna want to solve for dy dx in terms of u and x. So, y equals u minus x du dy dx equals um you know what, better way, du dx equals 1 plus dy dx. So dy dx equals 1 minus du dx. All right. So now let's substitute. We have 1 minus du dx equals tangent squared of u. So this is looking out to be very easy. Equals tangent squared of u plus 1. Make that a bit more clearer. That is actually secant squared u. So u, is that secant squared x or u? Oh, that's u. Oh. So I actually have to move this over here. So this has become cos squared u du equals dx. That's going to be 1 plus 1 half or 2. That's going to be 1 plus cos 2u du equals 2 dx. So now we've got u plus 1 half sine 2u equals 2x plus c. U is x plus y, so we have x plus y plus 1 half sine of 2x plus 2y. Let's just write this in terms of a level set, which is going to be 1 half sine 2x plus 2y, or better way, 1/4 sine, or sine of x plus y cosine x plus y plus y minus x equals c. All right, problem 19. Yeah, we want to do that. We have dy x equals 1 plus e to the y minus x plus 5. U equals y minus x plus 5 du dx equals dy dx minus 1. Or so we have du dx plus 1 equals 1 plus e to the u. Cancel. So we have e to the minus u du equals dx. Integrate both sides. We have negative e to the minus u equals x plus c. And then we have negative e to the y minus x plus 5 equals x plus c. Oh, would you look at that? Our answer is x plus
e to the y minus x plus 5 equals c. Did we have initial values? No, we didn't. All right. I believe we are now done with first order DEs. So we're not done actually. Let's go ahead and fix these. So our mu of x was correct. So 5 times x plus 2 to the 4 dx. We'll do a u sub, but that's basically going to be x plus 2 to the 5th plus c. Oh, that's not so bad. X plus 2 plus c times x plus 2 to the minus 4. All right, this one is good. This one, go ahead and erase that. We are about at the 2-hour mark, and we are barely into the 20 problems. Do I check my answers with Wolfram Alpha? No, I don't. If you want to, you can. Um, so let's go ahead and do integration by parts. So we've got e to the minus 2x. They're basically all gonna cancel. Equals that. Now we have y equals plus c, just negative 1/2 x squared. Minus 5 halves is gonna be 10 fourths plus 1/4 minus 11 fourths. Minus x over 2 minus 11 fourths plus c. No, I don't check my answers on Wolfram Alpha. All right, 2-hour mark, and we are entering question 20. All right. So we are finally back to some easy questions. The second order differential equations. Our auxiliary equation we get from subbing y equals, assuming it's in the form y equals e to the mx. We get 2m squared minus 3m plus 4 equals 0. Factoring, we get, that's just a quadratic formula. Yeah, quadratic formula. M equals 3 over 4 plus minus the square root 9 minus 4ac, which is 1632 all over 4. 9 minus 32 is going to be 32 minus 9, which is negative 23. So root 23i. 3/4 plus or minus root 23 over 4i. So alpha equals 3/4, beta equals root 23, not 34. So now we got y equals e to the alpha x, 3/4 x times c1 cosine of root 23 over 4x plus c2 sine root 23 over 2 over 4. What happened to the exponentials? They all got canceled out. We basically had e to the minus 2x times y equals e to the minus 2x times just a bunch of polynomial terms. E to the minus 2x canceled. I like that problem. Nice and short and easy. So this one's slightly interesting. We're solving an nth order differential equation. This is going to be m to the n equals 1. So since it's going to be recursive 1, not roots of 1, it's recursive 1. So just y is going to equal, screw it, let's just put a constant here, ky. Going to be the sum of all the recursive, which is going to be from n equals 0 to infinity, not infinity, to n of x to the n e to the e to the x and a k. So there's really nothing interesting to that. But yeah, we just solved this nth order differential equation. Hold on, there's got to be something more to that. Yeah, there should be a k here. Okay. Yeah, that's kind of boring, but hey, I was on there. So that one actually wasn't from the book. That one I made up myself. All right, this one should be slightly more interesting. It's a third order DE. Our auxiliary equation is going to be m cubed minus 6m squared plus 12m minus 8 equals 0. Some factoring, we got m, oh shoot. Let's see, hold on. If we do, not gonna work. Let's just do rational roots theorem. That's not gonna be good. So we got m. Let's just try m times m squared minus 6 plus. Ah, okay, yeah. We've got the negative 6m, or m squared plus 12 minus 6 times m squared, or this will be 2 times 3m squared plus 4. So we can obviously factor this, but how? There's got to be a way to factor this. Let's see if 2 is a root. We have 2, well, 1, negative 6, 12, negative 8. Haha, that was a good guess. Yo, I am so smart. I am so smart. So this is actually equals 2 3 times. So y is actually going to equal, so I felt like a smart person by guessing 2, but actually if I was really smart, I would have known that that is actually just m minus 2 all cubed. Is that true? I mean, yeah, obviously it's true. Did the synthetic division right? So y equals e to the 2x times um c1 plus c2x. All right. All right, so now we're on problem 23. This is a slightly better problem. Oh, we do annihilators on these. Dude, I hate annihilators. So our YH solution, okay, YH solution is gonna be 2/3.
C1 cosh 2/3 x, C2 sinh 2/3 x. So that's our, and then our general solution yg, gonna have the d squared plus 1 term. So then you get plus minus I. That's just the method that I specified at the beginning of the problem. We have C1 cosh 2/3 x plus C2 sinh 2/3 x plus yeah, a cos x plus b sine x. So yeah, our y particular equals a cos x plus b sine x. Yp prime equals, I'm pretty sure if we do yp double prime, we can just switch the signs. Negative a cos x minus b sine x. So now we have negative 9a cos x minus 9b sine x minus 4a sine x or cos x plus, not plus, minus 4b sine x equals sine x. So a is going to equal 0. And then we have negative 13b equals 1. So b equals negative 1 over 13. So we have our answer, C1 cosh plus C2 sinh minus 1 over 13 sine x. Okay. Oh, this is a yucky problem. So our annihilator is going to be d minus 1 times d. And then our y homogeneous solution, we're going to have so our homogeneous solution is, okay, we have m to the fourth, or just going to be m squared times m squared minus 2m plus 1. It's going to be m minus 1 squared. So we have c1 plus c2x plus c1 or c3 e to the x plus c4 x e to the x. And if we solve the annihilator thing, we're going to have plus a x e to the x, or x plus a x squared plus b x e to the x. So that's our yp is ax plus b x e to the x. Yp prime equals 2ax plus bx e to the x plus b e to the x yp double prime. Oh my gosh, I have to find multiple derivatives, like way too many, plus bx e to the x plus 2b e to the x yp triple prime equals bx e to the x. I just realized this should be an x squared, and therefore all this is wrong. And this is gonna take forever. So this is gonna take forever, and I might mess up. Plus left or d left right plus but I'm pretty sure a lot of things are going to cancel out. Um, yeah, the reason I'm not explaining too much is because I'm literally just too tired to talk. I would lose so much energy just by talking and explaining everything I'm doing, but I think it's self-explanatory. I'm finding the third derivatives. So this is 2b e to the x, 4b x e to the x. Oh yeah, plus 4b 4b e to the x plus 4b x e to the x plus 2b x e to the x plus, okay, so these and that cancel or add, so that's 6b. And then we got yp oh boy. Um, I just realized I could have added those. That's 6b e to the x. That's also 6b. 6b e to the x plus 6b e to the x. That becomes a 12 plus 6b x e to the x plus 2b. So that's going to be 8b plus b x squared e to the x. Now let's put everything together. So now we got bx squared e to the x minus, not minus, plus 8bx e to the x. So we're plugging this into our original equation. Minus, not minus, plus 12b e to the x minus 2 times y triple prime, which is 2b x squared e to the x minus 12b x e to the x minus 12b e to the x. Dude, I spent 30 minutes on this problem already. Okay, so that's our y triple prime. Then plus bx squared e to the x plus 4b x e to the x plus 2b e to the x plus 2a equals e to the x plus 1. Alright, let's find what cancels. This, that, and that cancel. So 8bx, so let's add the bx terms. We've got 8 plus 4 minus 12, so that cancel. 12b, 2b, or the 12 and 12 and cancel. So now we've got, yeah, 2b equals, b equals 1/2 and a equals 1/2. So we've finally gotten our b and a, so our solution is c1 plus c2x plus c3 e to the x plus c4 x e to the x 1/2 x squared 1/2 x squared e to the x. So there's a feeling in me that doesn't know if that's right, but I feel like that's right. 25, or problem 25. Alright. Well, a quarter of the way there to 100 differential equations. Oh, we already did that. Oh no. So this is our last annihilator problem. So our annihilator term is going to be d cubed times d minus 2. And what happens to be our y homogeneous? Well, we have m to the 4 minus 4m squared. So m's going to equal 0 twice and 2 twice. C1 plus C2x plus C3 e to the Hello, Jesse. What are you doing up so late? I mean, were y'all scared of the hurricane or not really? Never mind. Don't answer that. But you know what? It turned out to be not so bad in our area, which super glad, but also a little bummed out just because I was told that it was. See, I mean, I'm a little bummed out because I was told that we were at least gonna have something happening tonight, and now it just turns out there's like nothing going on, and they canceled school for nothing. Um, y oh yeah. So we have our d cubed, so we're gonna have to add plus, gosh, man, this is gonna be horrible. Ax cubed plus bx to the fourth plus c x to the fifth uh plus d e to the 2x, or d x squared x not squared, x squared e to the 2x. Yeah, okay. That, that's no biggie. Yp equals uh ax cubed plus bx to the fourth plus, just do yp prime. We don't even need to find yp. That's going to be 3a x squared plus 4b x cubed plus 5c x to the 4 plus 2d 2d x e to the 2x plus 2d x squared e to the 2x. Yp equals 6ax plus 12bx squared plus 5, not 5, 20 cx to the 4 plus 4d x e to the 2x plus 2d x to the 2x plus 4d x squared e to the 2x plus 4d x e to the 2x. So we could have added all these 4d x e to the 2x. Or not 4d, it'd be 8d. No, yeah, it would be 4d. So we add all these. 4 plus 2 plus 4 is 10 dx e to the 2x. Yeah. So yp equals 6a plus okay, nope, we messed up. Not badly though. So this is gonna be 4d x e to the 2x plus 4d e to the 2x plus 4d x e to the 2x, so we can add that. Then this becomes 8. And then plus 4d x squared e to the 2x. Error in the first line? Yeah, ha ha ha, funny. Okay. Differentiate that, we get 16d x e to the 2x plus 8d 8d e to the 2x plus 8d. So we got 16d plus 8d x e to the 2x, so 8d, so this is going to become 24 plus 8d x squared e to the 2x. Oh my goodness, we're almost there. That's 0. This becomes 24b. This becomes 240c. This should become a 3. This become a 2, so this becomes 160. So this becomes cx plus this becomes 20, or this will become 48d e to the x e to the 2x plus 24d e to the 2x plus 16 times 2, 32 d e to the 2x. Is there a reason for this? Actually, yes, there is. This is to prove that I'm good at differential equations, because I got a B in the class and I'm upset about that because the class was horrible. So I'm going to prove that I'm actually good at it by setting a differential equations world record. In terms of like the real life applications, nah, you'll never use this in real life, but so now we've got 32d. Maybe lose where I was. We had that. Okay. Differentiated that. So now was that after adding or before adding? Let's just add 32 to 24. What is 32 plus 24, guys? It is 56. Then plus 8d x squared that's actually going to be 16d x e to the 2x. So we add that to that. It's going to become 64. And then 16d x squared e to the 2x. Am I still being fed dinner? Of course. Okay, I put that status on there as soon as school ended for the summer because I was gaming while during my short summer break. But yeah, I'm gonna probably change it back to studying because I'm clearly not gaming anymore. Okay. So now let's go ahead and plug everything in. So now we've got 16d x squared e to the 2x. I'm going to write really small for this. D squared e to the 2x plus 56d e to the 2x. Or let's do this term first. 64 dx e to the 2x plus 56 d e to the 2x plus 160 cx plus 24b minus
um, 16d x squared e to the 2x. So I'm just plugging these values back into that. Okay, my vacation was a week long because um, I literally only had that a week off from school because I had an SAT strategies class that took up a lot of time. That was after my summer classes. Whose choice was it to do summer classes? Um, it was no comment. No comment. Nice breathing. Dude, I literally having trouble breathing because whenever I do stuff like this for a long time, it's tiring, okay? You try doing this. It's tiring, mentally tiring. I'm already slow. Dude, I've spent 3 hours. 3 hours? Oh, it's only going back 2 hours, so actually, I don't know how long I've been going for. Um, let's do, so, tell me when make sure when I hit the 12-hour mark, that or not near the 12-hour mark, I'm going to be ending the stream and starting a new one if I get to that point. Um, can I please solve this? So we had this term, now we just do the minus 80 cx cubed. Okay, so c is obviously 0. Um, d is very debatable. That's the problem. Okay, these and that will cancel. Okay, hold on, let me finish that. And then minus 12 times 4, which is 48, b, x. That means b is obviously 0. And then, or x squared. Uh-oh, b is not obviously 0 anymore. Then minus 24ax. Is it 24? Yeah. And then this is 5x squared minus e to the 2x. Dude, I'm probably going to get this wrong. Okay. We've got problems here. Got lots of problems here. First off, let's just say that 32D equals 0, but then we also have that 16D equals -1. Oh wait, no, not 16. 56 minus 16. 56 minus 16 is 40D, -1. Um, so I don't know what to do with this. C is definitely 0. As for B though, we have -48B equals 5. So D is -1 over 40. B equals -5 over 48. A is 0 and then C is 0. I hope that's right. I could be wrong. Could be way wrong. Okay. So, yeah, let's just go ahead and we're gonna put a star next to this one, meaning that it could be wrong. But, and then we'll come back to it. So we've got C1 plus C2x, C3 e to the x, plus C4 x e to the x, plus, wait, no. No, no, no. Okay. A and C are not obviously 0. We can work with this and maybe solve it. I say maybe. -48b x squared, any other x squared terms, equals 5. Yes, I plan on taking classes like that. No, what do you mean, Jesse? I know how to do, I'm doing physics, chemistry, business. I like those things too. I'm not just a math nerd. Okay, this problem genuinely has me sort of stumped. Let's go ahead and do 24b equals, this is 5. We have negative, that's what I don't understand. Sure, you can call me. You can't, they won't be able to hear you though. They can hear me only. Oh my goodness, I have got, hello? I can barely hear you. Dude, I can barely hear you. Hey, I'm trying to do a world record right now and you're ruining my time. Of course, I've done it before. Not enough caffeine yet. Okay, we're gonna put the star and we're gonna start a new problem. This is how far we got. So this is our temporary answer. Um, B, which was and then D was negative. So we are now a quarter of the way there, and we've been live streaming for um, about 3 hours now. So 12 hours approximately is our goal, but it's probably going to get longer as we do these longer problems. All right, this should be a semi-quick problem. Um, so our YH solution what? So, so U1 prime equals negative Y2, which is negative sine x times tan x all over. We're on skin, which is 1. So that's going to be sine squared x over cos x. Huh. So we're gonna have to do some, let's do sine x tan x. So u1 equals integral of tan x and negative sine x dx. U equals integration by parts, tan x secant squared x equals negative sine x cos x. Oh, there goes any sort of visibility. But basically that's going to become cos x tan x, which is just sine x, minus the integral of secant x sine x minus ln sec x plus tan x. So u1 y1 equals sine x cos x. Hold on, I'm gonna mute my mic for a little bit. Give me a second.
There's a freaking roach in my house and I didn't get to kill it. If I see it again, it's dead. Um, Hello, Jesse. Yeah, there's a roach in my house and I didn't get to kill it. Big sad. No, I couldn't see it. I couldn't see. It was the lights were off. No, we do have roach spray. I couldn't get to it. Because I couldn't see it. By the time I could see it, well, okay, anyways, how are you think, were y'all scared of the storm at all? Or not really? I know some people who like freaked out like crazy. Hey, if you're in the stream chat, can you hear me? Okay, so we got this cos x. All right. Um, no. I'm actually not breaking it. I'm setting it. Um, no. Yeah, no thanks. They're kind of boring. No, it's not. What do you mean it's totally clickbait? It is. I was gonna put I was gonna put like while hurricane passes over in the title, but then it just ended up not passing over. I was like, dang, I can't. It's already 2 a.m. It's already hitting. You actually heard thunder? Dude, it's been peace and quiet where I live. Dude, it's like peace and quiet where I live. Like, but yeah, what? Yeah, that's what it hears. All right, I need to finish these problems. I've spent 30 minutes waste not finishing problems. Okay. Um so uh oh wait, hold on. I didn't multiply, so this would be um the sine 2x terms cancel. This should just be um negative. Well, first off we have c1 cos x plus c2 sine x uh minus cos x ln sec plus tan x. Boom, solved. Probably. Yeah, of course. Because I just made it small. That's all. Dude, I hope that roach doesn't come over here. I mean, if it does, I'm screwing it up. But uh, there was a cockroach, and it was coming over here. Or not, it wasn't. It was actually in my dog's food. The dog food. Yeah, I know. He doesn't care. He eats poop every day. Or not every day. What do I need to explain? Okay. Yeah. No. I ended classes of second week of August. Third, no, yeah, second week of August. Okay. Yep, I just started classes. And they just ended for a whole week. Like they ended classes for Wednesday and Friday, or not Friday, Thursday. There's no class Friday and there's no class Monday because of Labor Day. So how long are you moving there? Oh wow, that is quite a while. Aw, not often. Actually, never. Hardly ever. Yeah. No, I don't. No. Do you not see the tablet? Yeah. It's an actual tablet. It's like another screen. I don't know. Um, all right. So we've got you. Okay, this is gonna be really annoying to work with. Um, because there are people bothering me during the day. Yeah, it is. Yeah. Yeah, the first week is always super easy, but then it gets crazy in like at like week 3 or week 4. Why? Um, maybe. No. Wait a second, what am I doing? If this is, okay, you know what? I don't even need to, screw it. I'm not solving this integral. The reason is because it's going to be in terms of weird functions. So we're just going to write it as for the solution as an integral defined function. So we do c1 e to the x plus c2 e to the minus 2x minus 1/3 e to the minus x ln x plus 1/3. Oh wait, no, I need to multiply it by e to the x. So that's going to be canceled. So that's going to be 1/3 ln x plus um, 1/3 e to the x ei of x. And then uh, e2, so plus e to the minus 2x times the integral of negative 1/3 e to the 2x ln x dx. Okay, that took a long time. Yeah, of course. Yes. Not really. It was pretty good for a little bit, then it sort of went downhill. And then I stopped watching it because I couldn't stand it. After he beat the game. I'm glad the stream can't hear you right now. Oh my goodness. This is really loud. Okay, I guess. Sometimes. Um, yeah. Okay, Ronskin's gonna equal, um, 4 minus 2 is gonna be 2 e to the 3x. Great. So now we've got, um, 0, 0, U1. Yeah, I know. U1 prime is gonna be 0, 0. Uh, no, I don't actually. I should get that. But okay, here's the thing. I don't have to drive to school. That was like one of the only reasons I actually wanted to get my license before school started. What? It's all online this year. Yeah, I know. I am. Okay, I I personally prefer in person too, but um I'm also glad that I don't have to drive to school. I used to do that, then I failed a test, and I was like, you know what? Let's not do that. Well, maybe because your stuff's easy, just a lot of homework. Is your stuff just easy and a lot of homework, or 2 minus 1, which is e? Oh, thank goodness. It shouldn't. Imagine it could. I would end it and delete it, but it shouldn't. Yeah, it doesn't. It doesn't. Because I have desktop audio off. So it's only recording my microphone and not my just so that I don't leak any personal information. Whoever you're talking about, I guess. I don't know. You don't care? Okay.
No. I've known him since I was very, 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 very young. Okay. It was 14 years ago. Oh my goodness, this is really annoying. Really annoyingly long. Uh, co-op. Is that a co-op? I think I was in the nursery. Okay. So we have found. Yeah, dude, these problems are taking forever. Why did I pick these? A book? The book we used? Yeah. Um, no. I already finished the class. Yeah, I already finished the class. Dude, I am getting increasingly tired, especially with these long, grueling problems. Like, oh my God. Okay, this is our last variation of parameters problem. Oh, that was only u1 prime, so we're now on to u2 prime, which is actually, hopefully, a lot simpler. And then we got, yeah, shortest would be 3 months, because that's a summer. Um, Pretty likely, unless I have class. Literally, that's the only thing stopping me is my 3 o'clock class. Is it 3 o'clock? Maybe 2 o'clock. No, 2 p.m. Yeah, I'm not sure if I'm gonna get to 100. I'm thinking 75 is a nice, cool number. Um, Afterwards, yeah, I'm gonna after like 50, I'm gonna be having to look up more because I only picked up to 50. Yeah, should be a negative, negative. Okay, hold on, let me make sure. Nah. Okay, and then this is going to be e to the 2x, e to the 3x. So this will actually cancel. Um, so um, I woke up at around 4 p.m. intentionally. Yeah. Ew, what was that? Okay. 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 Good night. Hey, what's up, y'all? That's good. I'm doing math right now. Uh, early college. Setting a world record. No, I'm setting a world record. The only help I need is just keeping sane. Because I'm gonna be streaming for a while. All right. Dude, I really hate the way I selected the problems for this world record. Yes. Most differential equations solved in one sitting. I'm it's actually not it's actually not breaking a record, it's actually just setting it. I'm gonna probably go to 75 because I picked a lot of long problems and like, the last problem I did, I just spent 30 minutes solving a third order non-homogeneous DE, which was not fun. We're using variation of parameters. That was not fun at all. Yeah, that's why I can do it for so long, is 'cause I don't have to think. A little bit. I mean, yeah, there's tons of formulas and stuff. They sometimes teach it in calculus too. I just know my freshman year of college, I really want to take Math 55. What calculus should be? That is unheard of here. The general definition of continuity from topology. Y'all are going to bed? Bruh, I'm staying up all night. Yeah, I'm working on this world record, and I'm gonna need y'all to give me some interesting DEs, or maybe not interesting, just some extra ones, because if I want to get to 75, nah, please don't do that many PDEs, okay? Only PDE I'm solving is the heat equation, 1D case. So, uh, dude, I'm not good at PDEs, okay? I haven't been exposed to them that much. So now I gotta do Green's functions on this one. Oh, there we go. No, I want a nice ODE. Give me a nice ODE. I actually solved one earlier. It was really simple though. It was just it was really boring. That's the thing. Because, actual 69th order ODE would require probably a computer algebra synthesis. Actually, no, Wolfram Alpha can barely solve like 10th order ODEs. So, um, a 69th order would be not nice. Get it what I said there? Okay, yeah, I know how to do that. It's really simple. You just sum the recursion, not recursion, whatever, powers of x times e to the x. Yeah, just sum of powers of x times e to the x. So, so right now I'm doing a Green's function problem. Actually isn't that hard. It's just a second order ODE with Green's functions. The whole purpose of that section was just to introduce us to the idea of Green's functions. Um, do I need boundary conditions? I think I do need some boundary conditions. No, I don't. For Green's function? Oh wait, yeah, I do. Wait, no, to get a general solution, I do need some boundary condition or initial conditions. So let's go ahead and do y of uh, um, dude, I was so happy they canceled classes today, but at the same time, I'm a little annoyed. They canceled classes because of the hurricane, and it didn't do anything to us, even though it was a crazy hurricane. I think a lot of people freaked out a ton, even though it literally like didn't touch us at all. Is anyone even here? Oh wow, there's like, are y'all like about to fall asleep? Okay, go ahead and send it in my PMs. I need like 25 of them. Off-topic voice. That's a system of ODEs. Come on, dude. I mean, I know that's an ODE problem and I could probably do it, but I'm strictly solving ODEs. But oh my goodness, that looks kind of tough. Oh my God. No, that actually looks tough. No thanks. Yeah, I do. Um, Integration by parts, we do differentiate that, we just get t, or we just get 1, so minus. Um, um, and then times evaluated at x at 0. Oh wait, no, this is y of x. And then we're gonna have okay, yeah. We're gonna have 1 plus 1. No, it's gonna be that's gonna go to 0, and that's just gonna go to e to the x. So negative 2 e to the x times the inverse tan. Oh no, that's our yp of x. Inverse tan of x. So our y general solution is going to equal c1 e to the 1/2 x plus c2 x e to the 1/2 x minus 2 e to the x inverse tan of x. So I'm wondering, how many cool points will I get on the server if I take Math 55? Hello? Hello, anyone? I asked, how many cool points will I get on the server if I take Math 55? Just search it up. I'm talking about the Math 55. Yeah. I think I'll elevate myself from just novice to what's a step up above novice? A knight. I'll be a knight. Mathematics knight. Not, I'm not an ultra cool boy like those grad school people, but I'll be a pretty cool boy. Then again, no, it's probably, I don't think it is graduate level analysis. I think it's like okay, so we're finding, and then, all right, so, um, equals, no, this is awfully quiet. I need to put on some music. I'm not going to use the music bot. Let me go ahead and use, first off, let me do this, then this, and this. Alright, this should keep me occupied for the next 3 hours. Alright. Um, oh boy. Okay. Just realized what that last problem was. All right, guys. I'm like getting really tired here, but I'm gonna keep going. Okay, so we got Cn. Okay. I'm doing all right. Right now, I'm just very tired, but I'm gonna keep going, and then I'll probably down my first coffee in a little bit. What? All right, let's just keep going. So right now, I'm using series to solve this differential equation. All right. Okay, so now we've got. So let's make our table. Oh my goodness. Dude, Hurricane Laura just completely destroyed that area. Okay, yeah, I know I've been just staring here, but this video of a skyscraper literally getting just destroyed by the hurricane, like literally just being ripped up. That's just scary. That could have hit us. That could have literally hit us, and that would have destroyed our city if that hit us. Wow. Wow, man. Wow. All right. Let's get back to solving some differential equations. Um, oh my goodness. Um, E1 all over. It should be 4 times 3. It should be C2, which is 0. C6, so this will be 0, 0. Hey, okay. C6 equals C0 all over. Yeah, thank you, Kilum. I am trying my hardest. Not C5, that's going to be C3 all over. Oh yeah, this is 0. C3 all over 4, not 4. This should be 6 times 5. Yeah, 8, 9, 10, 11, 12. I mean, we can do 11th case. This is going to be, yeah, 7 times 6. All right. I've spent 20 minutes on this problem already. C0 all over. Oh. Alright, we have beaten my previous record, which was 35. Oh, not yet. As soon as we solve this next problem. Oh my goodness. Yeah, just do the substitutions. Um we've got n equals 2 to infinity of Cn times n minus 1 x to the n minus 2 plus sum from n equals 1 to infinity C n times to the n minus 1. All right. Good luck. Yes, thank you. I need it. I seriously need it. I mean, I'm not gonna quit. Of course not. Never would. But, you know, it is gonna be kind of crazy. Um, what am I trying to do here? Yeah, I'm doing the substitution. This is gonna take a while. But let's try to work through this quickly. So now we got 5 hours. All right, and so now we got that. Let's do C3. Okay. Yeah, I've been pretty quiet this whole time. Just realized, I mean, there's like not really much to do, not much to think about, but it's kind of boring doing all this, but I guess it's worth it. It's gonna make me stop thinking about it. What am I doing? Yeah, B equals 6 over 16, which is 3 over 8. Okay, so I mean, we got that out of the way, but that doesn't explain the other like 10 variables we need to solve for. Oh my God. So I could proceed to do this partial fractions, or I could use something to do this. Because here's the thing, I'm trying to solve DEs, not partial fractions. We would spend the next hour solving this partial fractions. Um, Alright, so now we've got, alright, so this is, I'm getting very tired, obviously, and my handwriting is slowing down. So we need a 3 factorial, so it's going to be so yeah, right now we're just making everything inverse Laplace transformable, and we get our solution is we'll write it in descending powers of exponentials and stuff. It's gonna be 1/4
e to the RT cubed, e to the 2t, that's a minus, so minus 3/4. That's going to be a t squared, e to the 2t, and that's going to be plus 9/8 t, e to the 2t, minus 3/4 e to the 2t, plus 3/8 t, plus 3/4. All right. So we are now on to problem 40. At 5:30, I'm gonna take a restroom break, or 4:30. You know what? Yeah, I'm just gonna take it now. I need to take a restroom break. Or it's not really a break, but just a restroom stop, because there are no real breaks. But yeah. Alright, I need to turn on some better music for this, because this just isn't like cutting it in terms of keeping me sane. Okay. Okay. You know what? When I typically do these things, I need like a good podcast to keep me going. Oh my goodness. Oh yeah, let's just take the Laplace of this. And we got equals, what is this? This will be s minus 1 all over s. This goes to 0, so now we got, oh wait, no. We've got, let's try, okay, so we have s squared minus 2s plus r. So this one we'll do the partial fractions. We'll have 1. All right. So we got y of t gonna be that. Yeah, you know it's bad whenever I'm just doing that. Um, okay. Um, okay, yeah, there's a light at the end of the tunnel. So let's do this partial fractions. We got s minus 1 equals a times, so we have as plus b times s minus 1 times s plus, um, c times s times s squared minus 2s plus 2 plus d times s minus 1 times s squared minus 2s plus 2. We could do cover up, see how that works. It's going to be the same as if we did normal version. Just set up the system of equations. Okay, let's go ahead and do cover up first, right? S equals 0, we have -1 equals -1 times, let's have 1 equals d times, um, yeah, that's -1 squared, so plus 2. So that's 1 plus 2 plus 2, which is 5. dA equals 1. We have 1 minus 2 plus 2, which is 1. Yeah, 1. D equals 1. And that will help.
Yeah, I'm so quiet. There's like, it's like kind of hard to be loud when there's no one to talk to. You have negative b minus 2c plus 2 equals 1. So that becomes just a minus 1. So we have 2b minus 2c equals 1. Yeah, these will cancel. They equal the same thing. So we have negative b plus 2 equals 2b. Yeah, these both equal 1. So b equals 2/3. We have negative 2/3 minus 2c equals negative 1. Then negative 2c equals negative 1 plus 2/3 and negative 1/3. C equals 1/6. So A equals negative 1/6 minus 1/2, which is 3/2. It's going to be a negative 2/3. Now we can finally get back to our Laplace transform question. Oh, I forgot. We haven't even gotten to the worst part yet.
All right, there we go. That's good. Handled the A's and B's, and then D and C is plus 1/6 1 over S minus 1, and then um plus 1/2 over S. So equals our answer, which is -2/3 e to the t cos t plus 1/6 e to the t plus 1/2. All right, let's go ahead and try Annihilator. Nah, let's do Laplace. Yeah, we have s squared y minus 2 r minus s y of 0 s y prime of 0 2 s y plus 2y of 0 5y 1 plus so we've got Hmm. Oh, yeah. C times let's see what we got here. What did we put? Yeah, 1 over S. And then D, which was 1/5, times 1 over S squared. So our y of t equals negative 2 over 25 e to the 2t cos 2t plus 2 sine, or no, 2 over 25, 1/5 t plus 2 over 25. All right. So we're almost at my original goal, which was 50. And I could honestly go, so we're at 42 at around 6 hours. That means we'll be at 81 at about 12 hours. Can I make 12 hours? That's 11 a.m. Yeah, that'd be yucky, but we can do it. I think we can get to 75. But I also kind of want to go to sleep. But I also want to kind of stay awake. Oh, wait, no. I need to go to sleep. I just realized, yeah, I do need to go to sleep. Shoot, it's 5 a.m. Let's see how we can do this. Yeah, let's just get to 50 and call it a day. I could definitely go further, but yeah, who cares? Oh, finally, the easy problems. Uh, all right. how do I do this? It's basically we want the roots of k, but I completely forgot this. So k, negative k also equals e to the I pi k, right? No. K over n. Oh, okay, yeah. E to the I pi k over n equals m. There we go. What's up, Asish Singe Singish Sing? Oh my goodness. I have no clue how to pronounce your name. Let's see, so we got that. So e to the I pi k over n times x, and then so we want the cosine of that, because that will be the e to the cosine of pi k over n x times c1 cosine of sine of pi k over n x plus c2 sine of pi k over n times x. Yeah, if um wait, no, yeah, that's right. This should work for any. No, that's right. We're gonna have the recursive roots, and y equals. Hello, AR77. Um, that's what I don't know is if it. Yeah, it should mean uh recursive. No, I don't think there's any if statement here. It's just sort of like it's like this. N, yeah, that's the same N. All right. All right.
How many coffees have I had? I've actually had zero. And the reason for that is that I'm actually not going to be staying up that much later. I thought I had a lot of time, but it turns out I have a class tomorrow, so I'm gonna need to get to bed. Um, I'm gonna have to get to bed. Yeah, I've had no coffees. Um, I have class in the morning, so I'm just gonna go to bed after I hit 50. And I might do this again someday, but like personally, I don't find it that interesting. So right now, I think I'm just doing the differential equations from physics. So divide everything. We got x double dot. We have All right. I'm pretty sure it's I'm not sure how we get to there.
Now, there's got to be something. Well, we'll look at that in just a second. But case 2 is when it is critically damped. Now, this is in the case where we have um, two roots at. Okay, no, that's what the case I'm talking about, where that was case 2. And then case 3 is when it's overdamped. That's when lambda squared minus um, critically damped. And then, so since it is critically, when it's underdamped, this is when we have harmonic oscillation. So then let's find the roots. That's omega squared. So we have um, square root negative uh, lambda. That's right. Negative lambda plus or minus the square root. So this is going to be I times the square root of 4 omega squared minus lambda squared. Um, is that right? Yeah. So that means square root of 4 minus lambda squared equals r. I don't know what to call it. B and r beta, then r. We'll just call this mu actually. Nu, whatever, beta. And then r negative lambda equals r alpha. And now we've got x of t equals um, e to the negative lambda t times c1 cosine of square root 4 squared minus lambda squared t c2 sine square root 4 omega squared minus lambda squared. All right, and that is our oscillation stuff. Now we just have a simple problem. All right, thank you, my dude. That's what everyone should be doing. Unfortunately, they don't want to tell people about this, so yeah, I'm not sure how much longer I want to go. Um, 'Cause I have class at 3, which is I'm also just tired in general, and I'm also really hungry, and um, yeah, but let's just keep going. Get to 50, and we'll talk about it from there. Um, that should be a minus y of 0, then plus y equals e to the minus as. Then this is a. So now we have. So now we just add a. Okay, yeah, fine. Y of t equals inverse Laplace of a over s plus 1 plus e to the minus as all over s plus 1. So this is almost in the form of the unit step function. So first off, we've got this equaling a e to the minus t plus delta. It's almost hold on. This is like a inverse Laplace I haven't seen before. This is either the unit step or it's a product of stuff. Because there is a function to describe this. Oh, it's the Heaviside step function. Yeah, I got it wrong. It's a Heaviside step function. I remember now. Times the e to the minus um t minus a. Or if you want to interpret this as some t0, so that's the Heaviside step function. Um, all right, next problem. Okay, we're getting to the two funnest problems of them all. So this one's gonna take a little bit.
This is our first partial differential equation. So yeah, there's some certain things we need for separation of to do the separation of variables, but we're gonna basically make it into separation of variables. So let our u of xt, our solution, be some product of functions capital X times t of t. So x of x and t of t. And also our full function, so that's our un, and our full function is the sum of these. So what doing this allows is when we take derivatives, so let's find our u, our derivative of u, du dt is going to equal x, or x of t, so we'll just abbreviate this as x times t dt, and this is just a normal derivative. So then if we have, now let's find our second derivative of x. This is going to equal just normal d squared x. And then with respect to little x, I think I'll just sort of curve it to make sure to emphasize that these are different x's. So, but the thing about x is that this is position, this is temperature at some time and position. So we're gonna plug this into our equation. We have x times dt dt equals dx d squared x dt or dx. Oh, squared. And then we want the x terms, and then, oh, there should be a t here. Yeah, because this. So we have a t. So now we want to flip-flop so that we have the t variables on one side and the non-t variables on the other. No. Now we have 1 over t dt dt equals 1 over x times d squared x dx. And this is still big X, and this is just little x. and this is going to equal a constant because this is going to equal some constant, right? And this constant could either be positive, um, could either be a positive integer, a negative integer, or 0. But we can show that it's just gonna work only for the if we do 0, we get a trivial solution, and if we do this, we get a contradiction. So it's gonna be lambda squared or negative lambda squared. So now we have our 1 over t dt equals negative lambda squared, and our 1 over x d squared x dx equals negative lambda squared. And basically the reason we get a contradiction for this is that whenever we let t go to infinity, our solution goes to infinity, and that's not supposed to happen. So now that we solve it, we get so for this we get t equals some constant a e to the negative lambda squared t. Right, we just integrate and then do the e to the that part. And then for the second order one, let's just we can rewrite this as dx minus plus x, and then this is little x, don't forget, equals 0. And now we know from the formula that x is going to equals the oh yeah, cosine some constant b, I mean I guess c1, so yeah, b cos lambda x, or yeah, and then yeah, because it's dependent on x. It's just weird working with the c sine of lambda x, right? So now we've found our x and our thing. We know that they're a product. Now we know our u function is going to be, so this is our original question. We got all this from that, but is going to be the sum. But we need to know these coefficients for our an. Oh, and also we need to find our, using our boundary conditions. So we've got u is going to equal a, a times b. The a times b is going to become another constant. So we have e to the negative lambda squared t times c1 cosine of lambda x plus c2 sine of lambda x. So don't forget about our boundary conditions from right here. So we know that when u is 0, x is 0, or when x is 0, u is 0. So when x equals 0, u equals 0. So we have 0 equals to the minus, this is going to become 1. So of, oh yeah, this goes to 1. So we just have C2 sine of lambda L. And this is going to be a little special. So this is C whatever. We know that lambda times L is going to have to be a multiple of pi times L, this inside. N pi lambda L, so lambda n equals n pi over L. So now knowing this, we can write u finally, hold on. So lambda n, not lambda equals, lambda n equals, so yeah, this is only 0 and this happens. Not 1, whatever, equals pi, n pi, multiple pi, not lambda, over L. Just because, okay, so basically sine is 0 when they're multiples of pi, and then we just solved for lambda n. Okay, so now we can combine it, and we have our u and our sum, since it's a linear, n equals 1 to infinity of an of, this is going to be, what was I thinking? E to the minus lambda squared t sine of lambda n x. And then also for this, n has to be a positive integer. That looks horrible. So we're gonna have to make this into a special form in order to rewrite this into an integral. Our integral is going to be in the form of integral from a to b of our r of x times ym dx, which equals 0. So this works and this works. And then we've already found our ym and yn. So this is going to equal, so now we've got our phi of x, which is, let's have this be our phi of x. So now we know that this is equal to 0. This has to be our phi of x from this. And now we've got um, this equals dx equals the sum. Oh wait, no, not the sum. We've got to have our, this phi of x is going to equal this. Yeah, the sum that we had earlier. An sine of lambda n. Okay, and we switch the sum. Oh yeah, and because because of certain things, whenever this only everything cancels out unless lambda equals m. Sine squared of this, and we'll just switch the n to the m from now, because we combine the terms. So now we've got our am. When we evaluate this, we've got am equals an or am, whatever is going to equal 2 over L times the integral. So we basically evaluate this integral. We get phi of x sine of lambda x dx. So our final answer, I'm going to write super small for this, u of x t is going to equal the sum from n equals 1 to infinity of the 2 over L times the integral from 0 to L of phi of x times sine of lambda n times x dx times e to the negative lambda squared, or lambda n squared t, sine of lambda n x. And lambda n equals n pi over 2L. So I guess I could abbreviate that, but n pi over L, and n is a number of the integers. So this one is also pretty interesting. Did I skip one? Huh, maybe I did one twice. Maybe I skipped a number here. Huh. Maybe I skipped one of the Laplaces. Oh, yeah, I did. Okay. I think I skipped the first one. So yeah, this one's very simple. That one was number 37. Let's check if it was the same. Yeah, it was different. Okay. So this isn't 49, this is 48. This one's pretty simple. Y prime plus 4y equals e to the minus 4t. Oh, now we take a Laplace both sides. You got sy minus y. Oh, our initial conditions are y of 0 equals 0. Let's see if we can finish before 6 my time. Dude, I don't think you need to try hard Laplaces. I mean, maybe Fourier, but yeah. All right, so let's get 4. This is 4, just a y equals 1 over s plus 4. That's 0. So we just have y, yeah, y of t equals inverse Laplace of 1 over, that's just going to be s plus 4 squared equals just yeah, t times e to the minus 4t. That was easy. Let's do another slightly easy one before our last one, which I actually like quite a bit. We just got this random one. Well, I say last one because I'm short on time. So we're gonna do a u sub. Yeah, like that. All right, so now we've got so this is a very, it looks rough looking, but it's actually I think separable. Let's check. Either separable or, oh boy, no, that looks unsolvable. Hold up. I really hope it's separable. Let's just move this du over dx. Okay, I really think this is unsolvable. Um, yeah, I'm not sure what I was thinking here when I made this. I mean, I guess I could do. Yeah, okay. So this problem was trash. That problem was trash. Don't worry about it. Garbage problem. I really don't know what type of problems I need. I guess we could do another Laplace, but that's kind of boring. I mean, I guess in the spirit of doing physics equations, we could do the circuit one, but that's kind of not useful. Well, okay, it's useful, but it's not like cool at all. Let's do let's just do this one. You have so what you want to do here is add 2 and also subtract 2. This becomes 1. Now we do our use substitution. So now we've got this going to be minus 2 or minus 3, so plus 3. 3 plus 2 is 5 minus. So this is 5u minus 4 over u. So u 5u minus 4 du dx. Integrate both sides. And then you could just do divide. plus 2 minus 4/5. All right, on to problem 50, which I think I'm going to cut it off after this one. We've got a general third order equation. In this case, we're going to want to use Cardano's formula. So we've got our auxiliary equation, which is am cubed plus bm uh, equals negative c. So now we know that m is going to equal cube root of a over, not a, negative c over 2 plus the square root of n squared n over 2 squared, or negative c over 2, c squared over 2, not 2, 4, plus b cubed over 27 minus the cube root of negative, not negative, positive c over 2 plus the square root of c squared all over 2. C squared all over 4 plus b cubed all over 27. So, there's three cases. Case 1 is when c squared over 4 plus b cubed over 27 greater than 0, in which case y is just going to simply equal c1 e e to like the first answer of this. Okay, this one isn't coming out to as cool as I thought it would be. I don't think this one's gonna be good. Yeah, this is boring. Okay, we're doing a different last question. Give me a good ODE to solve. Someone give me a really good ODE to solve. Because that's what I need right now. Yeah, I'm good. I need a good ODE to solve. Um, where can I find a good ODE? Let's check my book. Guess I could do the logistic one. Like, there's really nothing I know that would be good to solve, other than maybe like a Green's function problem. Yeah, okay, this is the last question. So I can see why this doesn't work. So I'm gonna say, um, there we go. Like that. Okay. I mean, I guess you could change the delta k's. So this equals 0. Now this is a Cauchy-Euler DE. So y n prime, if it's in the Paulin form, m choose n x to the m minus n. Is that right? Yeah. So that's what that equals. We substitute that in. And now we have x to the m times m choose n over n factorial equals 0, which I don't think that can happen. Hold up, I don't think this can happen. So I guess I could make it equal like 5. Let's just say this equals some number uh, a. So now m choose n, or basically we had it to where it was like product m choose n is m all over n factorial minus n factorial all over n factorial. So this equals a, so we have m factorial over m minus n factorial, which equals a. We need to solve for m in terms of n and a. I don't think this is m choose n though. Basically, it's a product all the way down. Okay, so now we've got this j. Whatever. And then so now we can cancel that. Oh no, we can't cancel that because now that equals a. Okay, fine. So when it equals 0, there's no solution. Oh, there is a solution. It's a trivial solution. So over n factorial. Okay. That was kind of lame, but I guess that was the way we had to solve it. Was just, I guess we could sort of prove that there's no other solution, but I guess that was fair. I guess that was fair. So I think I'm gonna end it here. I've got class later today and I still need to sleep. I didn't use any coffee though, which is I guess impressive. How long did I go for? 7 hours and 15 minutes. That's pretty good, I guess. Yeah, thank y'all for joining me. It's kind of lonely most of the time. But yeah, if I ever want to break this again, no, I never want to break it again. I'm gonna do a more interesting stream that I think everyone will like. So, yeah, I'll see y'all later. But yeah, this is the world record. We're keeping it at 50.